Here we'll look at an important limit, the limit of 1 over x as x approaches infinity. It's not something that we can just plug into calculator. So instead, what we'll do is we'll come up with some x values, which we can plug in, and hopefully use the outputs to determine what the limit is. Now I want to go to infinity, so I'm going to make my x's 0 through 4, and then I'll throw in 10 and even 100. That way I'm getting really big values of x. If you plug in 0 into the formula, that's undefined, so the function doesn't exist there. 1 over 1 will be 1. 1 over 2 is a half. 1 over 3, approximately 0.33. And 1 over 4 is 0.25. So clearly our values are decreasing as x increases. And it looks to me from the graph like they're headed towards 0 as an asymptote. Let's try 1 over 10. On calculator that gives us 0.1, and then 1 over 100 gives us 0.01. And just conceptually, dividing a real number by something that's infinitely large means that our limit here is going to be 0. It is trending towards 0. Now we're going to use that idea to solve more difficult limits involving infinity. Take this number 1 at the bottom, for example. It says find the limit as n goes to infinity of 2 plus 3n. Well, we can't just plug in infinity into that. And here's why. You'd get 2 plus 3 times infinity over infinity, but there's no infinity button on the calculator. And 3 times infinity is still infinity. And 2 plus infinity is still infinity. So the problem here is that we get an indeterminate form. However, is there a limit of this function as n goes to infinity? Well, by looking at the graph, we can show that there actually is. So I'm going to switch programs here. I'm going to go to a web app called Desmos.com. And what it'll do is it'll allow us to just graph that function and just see visually what its limit really is. Okay, so as you can see, as x goes out to infinity, our value of the function seems to be approaching 3. And so there is going to be a limit of 3 that it approaches as an asymptote. And what I'm going to want to do now is I'm going to want to find that through algebra. And so let me show the technique here for doing it. We want to find the limit as n goes to infinity of 2 plus 3n over n. We want to identify the largest power of n that appears in any term, and that's just n. And so what we'll do is we'll rewrite our limit. It'll become the limit as n goes to infinity of 2 over n plus 3n over n over n over n. I divided every term by n. Now what I'm going to do is try to simplify and see what gets left behind. It's going to be the limit is n goes to infinity of 2 over n plus 3. It's in a different form now. So what if we did plug in the infinity at this time? We would have this. And can we reason out what the final answer should be? Well, the fact is, we said before that 1 over infinity was headed towards 0. So 2 over infinity is headed towards 0 too. So that means our final answer is found to be 3. Now there's a couple other problems on here too. Let's see, the limit of x squared plus 3 over x squared minus 4. Okay, let's try that one. We want to identify the largest power of x that appears. That's definitely x squared. And so we're going to want to rewrite this, but by dividing every term by x squared. Keeping in mind, though, that this is a limit as x goes to infinity. Okay, that's a lot, but let's cancel what we can here. That'll become a 1. And this will become a 1. And that'll leave us with a limit. X goes to infinity. 1 plus 3 over x squared over 1 minus 4 over x squared. Keep in mind, though, that we're going to now plug in infinity into those x's. And if you have infinity squared, well, that's still infinity. So 3 divided by infinity, that's going to go to 0. So let's write that. 1 plus 3 over infinity squared. 1 minus 4 over infinity squared. These parts go to 0. And that leaves us with just 1 over 1, which gives us a final answer of 1. 1 is the answer to that limit. And we'll do one more here. Let's do the limit as x goes to infinity of x squared plus 5x plus 1 over x cubed minus 4x minus 7. Okay, first we'll identify the largest power of x that appears. That would actually be x cubed. So we want to make sure to divide all terms by x cubed. It'll take a little bit of work and simplification. Okay, now when I do x squared over x cubed, we're going to see that we'll get 1 over x. That is because the x squared here cancels with x's down below, leaving behind just 1x. Up here we're going to get 5 over x squared. This one can't be reduced, so we'll just leave it. And then we'll have 1 minus 4 over x squared minus 7 over x cubed. And we want the limit as x goes to infinity. So some of these can just be plugged directly in. 1 over infinity plus 5 over infinity squared plus 1 over infinity cubed. And then we'll have 1 minus 4 over infinity squared minus 7 over infinity cubed. And it should be clear that by the same reasoning that we had used before, some of these totally disappear because they will become zeros. This goes to 0. This definitely goes to 0, and so does that. This one will go to 0, and so will this one. But the 1 can stay. So, final answer, we're going to get 0 on top and 1 on bottom. The limit of this is 0.